Excluded values. All right. Now what we're going to be doing today is we're going to be kind of adding on to what we did last week. So let's get started. To find excluded values, you must do what? Number one, simplify the rational expression. That's the first thing. Simplify the rational expression. Number two, set the denominator equal to 0. And then number three, solve the equations. All right. I'll give you guys about a minute to get that. And we'll look at some examples from the problem set. All right, let's look at number one. All right, number one is x plus 4 over x squared plus 6x plus 8. All right, for this one, we cannot factor the top. The top is already fully factored, but we can factor the bottom. So can we multiply to 8 and add up to 6? Yes, we're going to need 4 times 2. So we can break this up into x plus 4 and x plus 2. So that way the two numbers will multiply to 8, but at the same time they'll add up to 6. So what is the same on the top and bottom? What is the same? The x plus 4, right? So I can cross those out. And when I'm done with that, I'm left with 1 over x plus 2. Okay, so that is simplifying. All we did was we factored the top, we factored the bottom, and we canceled out common factors. So now what I'm going to do is I'm going to do step 2. I'm going to set the denominator equal to 0. The denominator is always going to be the bottom of the fraction. So I'm going to take this right here and I'm going to set it equal to 0. All right, so I got x plus 2 is equal to 0. Now what I'm going to do is I'm going to solve the equations that I get. And I've got to solve them for the variable. So to get rid of this plus 2, I have to do what on both sides? I basically got to do the opposite of adding 2, right? I've got to subtract 2. So I do that first. I subtract 2, and since it's an equation, you got to remember to do it on both sides. So over here, I have plus 2 minus 2. Those are actually going to cancel out, so I don't need to worry about that anymore. I bring down my x, my equal sign, and then I do the right side of the equation. 0 minus 2 is negative 2. So that's going to be my excluded value. Okay? Let's try number 2. All right, on the top, I have x squared plus x minus 6. And on the bottom, I'm going to have x squared plus 8x plus 15. All right, for this one, I noticed that I have 3 terms. 3 terms on the top, 3 terms on the bottom. The leading coefficient is 1, so I can do the adding and the multiplying. So what'll multiply to -6, but at the same time add up to a 1? Some kind of 3 and 2. And then I just think, okay, which number needs to be negative? Because one of them needs to be negative so that I can multiply to -6. But at the same time, I've got to add up to a positive 1. So that means the smallest number has to be negative. I'll put that negative on the 2. So on the top, I have what? X plus 3, x minus 2. All right, what about the bottom? I need to multiply to 15, but at the same time, I need to add up to 8. So 3 and 5. I get x plus 3, x plus 5. All right, so what's the same on the top and bottom? The x plus 3's, right? So I can cross those out, and then what am I left with? X minus 2 on the top, and x plus 5 at the bottom. Good. So that's my simplified form. So now what I'm going to do is I'm going to set the bottom equal to 0. So I get x plus 5 equals 0. All right, so at this point, I need to solve for x. I've got plus 5 on this side. I want to get rid of that. So I need to do the opposite on both sides. I need to subtract 5 from both sides. So when I do that, what happens? Well, the 5 minus 5 cancel out over here. So I don't need to worry about that because 5 minus 5 is 0. And if it's 0, I technically don't need to write it. I bring down my x. I bring down my equal sign. And then 0 minus 5 is -5. So that's my excluded value. Okay, so all you're really doing is you're doing the same thing you did last week, which is just simplifying. And then when you get to the very end, you're always going to set the bottom equal to 0. It's never going to be the top. It's always going to be the bottom. Because when you have a rational expression like this, where you have something in the top and something in the bottom, you really can't be dividing by 0 at any point during this. So that's the reason why the denominator has to be set equal to 0. So that way you'll find out what x cannot be, okay? So we always set the denominator equal to 0, not the numerator. The numerator can be 0 all it wants. All right, let's take a look at number 3. Okay, for number 3, we got 6x squared plus 12x. And then on the bottom, we have what? Let me zoom in right here. We got 18x squared plus 36x. All right, so what can I do to the top and what can I do to the bottom? Let's just look at the top first. What do both of these terms have in common? They both have an x, that's right. So we can take an x out. But what else do they have in common besides that x? Well, 6 and 12, I can divide both of those numbers by 6. So I know I can take out a 6 at the very least. So I know that 6x is going to be called my GCF, the greatest common factor. It's got to be what they have in common. Now I just see what I have left on the inside. I took out a 6x. So to get back to 6x squared, I'm going to need another x. So I'll put that right here. And then I need a plus in the middle. And what do I have to multiply 6 by to get back to 12? What do I need to multiply 6 by to get back to 12? I need a 2, right? That's going to go over here. Okay. Now, what can I take out from the bottom? I can divide 18 by 18, and I can divide 36 by 18 to get 2. So I can take out an 18, but not just an 18. I can take out an 18 what? An 18x, since they both have at least one x, right? They got to have it in common for them to be taken out. So now what am I left with? I need an x, I need a plus, and then what do I multiply 18 by to get back to 36? That's going to be a 2, just like I did on top. So now that I've factored the top and the bottom, what can I cancel? What's the same on the top and bottom? I can cancel out the x plus 2's, right? Then I can also cancel out the x's, right? So those are gone. And now what's 6 divided by 18? That's going to be what? Well, I can divide the top and the bottom by 6, right? So if I divide the top by 6, what would 6 divided by 6 be? That would just be 1, right? Then if I divide the bottom by 6, 18 divided by 6 would be what? 3. So now I have 1 over 3. That's the only thing I have left. And that's it. That's our simplified form. So now what I do is, to find excluded values, I always set the denominator equal to 0. So let's try setting the bottom equal to 0 and see what we get. So I set 3 equal to 0, and immediately I am faced with a problem. 3 can never be equal to 0, right? So 3 is really not equal to 0. So if you run into a problem like this, you just write no excluded values. No excluded values. Okay, that is number 3. All right, let's try 4. And I'll zoom out so you can see 3 again. Let's try number 4. For this one, I got x squared plus 6x plus 5. And in the denominator, I'm going to have x plus 1. All right, so for this one, can I factor the top? Yes. Only if I can find 2 numbers that multiply to 5, but at the same time add up to 6. So what 2 numbers multiply to 5? 5 times 1. 5 is a prime number, so I'm pretty much only going to have 5 and 1 to work with. And they do add up to 6, right? Because 5 plus 1 is going to give me 6. So I can use these 2 numbers. So on the top, I have x plus 5 and x plus 1. Just using these 2 numbers right here. The bottom can't be factored, so I just leave it on its own. Okay, so now what's the same on the top and bottom? What can we cancel out? We can cancel out the x plus 1s. So those are gone. Now, what do I have left at the top? Just an x plus 5, right? What do I have left on the bottom? Well, I don't have anything at the bottom, so I need to leave a 1. So now, if I'm dividing by 1, that really just means the numerator is going to be the answer. So my answer is going to be x plus 5. Now, since I only have a x plus 5 and there's really nothing left in the denominator to speak of, I could let 1 be equal to 0. But of course, you know from the previous problem that you can't do that because 1 really isn't the same number as 0, right? So this is no excluded values. No excluded values. All right, let's take a look at number 5. (8x to the 30 power over 4x to the 31 power). Okay, so for this one, we can't really factor. We can only cancel out common factors. So looking at these two numbers over here, 8 divided by 4 would just be 2. So the 2 stays on top, the 1 stays on the bottom, but I really don't need to write the 1. And the last thing I do is I work with the variables. So when I'm working with these, I know I have 30x's on top, and I know I have 31x's on the bottom. If I can get rid of 30x's at the top, then all these are gone, but I still have to get rid of 30x's on the bottom. So if I start off with 31x's, but I get rid of 30 of them, how many do I have left? 31 minus 30 would just be 1. So what do I have left on the top? Just the 2. And what do I have left at the bottom? Just an x to the 1 power. So you can write that as 2 over x, or you could write it the same way as 2 over x to the 1 power. These are the same answers. So really, I could write it either way, and they would both be correct. Now we set the denominator equal to 0. So let's go ahead and do that. And since x is already by itself, I don't have to solve for anything. That just means that 0 is going to be my excluded value. So we can't let the denominator be 0. All right, number 6. Let's take a look at this one. And then maybe after that, we can get to some classwork. All right, number 6 is going to be x squared minus 3x plus 9. And in the denominator, we have x cubed plus 27. All right, so what can I do here? When I look at the top, I could factor this by multiplying to 9 and adding to -3. But what two numbers will do that? What will multiply to 9? 3 and 3? Now, if I'm multiplying to a positive 9, either they're both going to be positive or they're both going to be negative. And either way I try it, I'm never able to add up to a -3. So the top is actually going to be prime. This is going to be prime. But can we factor the bottom? Let's try that instead. These are cubes, so I need to start finding cube roots. All right, so what's the cube root of 27? That would be 3. And what's the cube root of x cubed? Wouldn't that just be a regular x? So I start off like that. And then for the long factor, I need to start squaring my cube roots. So what happens if I square x? You get x squared, right? What happens if I square the 3? You get 9. And then the last thing I do is I multiply my two parts together. So 3 times x, that's going to give me 3x. Okay, same, opposite, always positive. I bring down the same sign, that's going to give me a plus. Later, I'm going to choose to the opposite sign, so that's going to be the opposite of a plus. That would be a minus, right? So I put a minus right here. And the last sign is always positive or always plus. So I put the plus sign right here. Okay, so that's really what the bottom is going to be. So let's go ahead and rewrite this down here. What I'm going to do is I'm going to keep the numerator the same. And the denominator is going to be pretty much what I just found down here. The x plus 3 and the x squared minus 3x plus 9. All right, so what matches up on the top and bottom? The long factor, right? They're the ones that are going to match up. So if they're both the same thing, I can cross them out. I don't have anything left on the top anymore, so I put a 1 in its place. And then the denominator is x plus 3, because that's the only thing that's left. Okay, now we set the denominator equal to 0, so what's going to happen there? I get x plus 3 equals 0. And then I solve for x. So I subtract 3 from both sides. These cancel. I bring down my x and my equal sign, and 0 minus 3 is negative 3. So negative 3 is the only value that x can't be. Because think about it. What if x right here really was negative 3? I would have negative 3 plus 3. That would be 0. So we'd be dividing 1 by 0. And we can't do that, right? That's the only reason why we have excluded values. It's because the denominator can't be equal to 0 at all. That's the only number that x can't be, negative 3. Okay. Let's look at some classwork problems. And I'll probably just pick the hardest ones and do those. Okay, classwork. Okay, I'll be skipping number 1 and number 2. Let's just go directly to 3. So for this one, I've got 2x squared plus 10x, and at the bottom I have 3x squared plus 15x. So here, I can take a 2x out of everything, and I'm left with x plus 5. Down here, I can take a 3x out of everything, and I'm left with an x plus 5. And that's good because the x plus 5s are going to match up. The x's are going to match up. So the only thing I'm left with is 2 over 3. And since 3 cannot be equal to 0, we say this has no excluded values. Okay, so that's number 3. let's try number 7. This will probably be the last one I'll be able to do. All right, number 7. We have x plus 1 at the top. We got 3x squared plus 8x plus 5 at the bottom. Because there's a 3 out in front right here, we can't just multiply to 5 and add up to 8. That wouldn't even really work anyways. We're going to have to use what's called the rainbow method. So this one is rainbow. So I draw the rainbow from the first number to the last number, and I multiply 3 and 5 to get 15. So this is going to be my multiplying number, and 8 is going to be my adding number. Now what I can do is think of the two numbers that multiply to 15 but add up to 8. We all know that's going to be 3 and 5. So what I can do is leave the top for same right now, and the bottom, I can break this down into 3x squared, and then the 8x is going to split, right? This 8x is going to split. 3x and 5x. And then I bring down my plus 5. Okay, so now I can group them. I can do this and this. The top is still the same. This hasn't changed at all. But the bottom, I'm going to be able to bring out stuff, right? So what do these two terms have in common right here? They have a 3x in common, and I'm left with x plus 1. Over here, I can take out a 5 that's in common, right? When I do that, I'm left with x plus 1. So now I regroup. The top stays the same because I haven't changed it yet. On the bottom, I can put the GCFs together to get 3x plus 5 and x plus 1 is on the inside. Okay, so now it's fully factored. What's the same on the top and bottom? The x plus 1, right? So now that I have nothing left on the top, but everything is left on the bottom, I'm going to keep a 1 at the top. The 1 is going to stay at the top, but what's going to be on the bottom? The 3x plus 5. And that's pretty much it. I cannot reduce anymore. Okay, so now we've got the simplified form. Now I set the denominator equal to 0 to find the excluded values. It's basically going to look like this. 3x plus 5 equals 0. And I pretty much just go from there. So to get x by itself, I've got to do opposites, right? If I see a plus 5, I'm going to do the opposite of that. I'm going to subtract 5 from both sides. So over here, the 5 minus 5s are going to cancel. The 3x gets brought down. And the equal sign. 0 minus 5. 0 minus 5 is negative 5, right? So now I just have 3x is equal to negative 5. And then the last thing I do is, since this 3 is being multiplied by this x, I do the opposite of multiplication. And the opposite of multiply is divide, right? I'm going to divide both sides by 3. And then I get x is negative 5/3. Let me zoom out so you can see that. Okay, so that's number 7. Your reduced form is 1 over 3x plus 5, and the only thing that x can't be in this problem is negative 5/3. And of course, the 3's cancel out up here, so you don't need to worry about those anymore. Just the x gets brought down. Okay, so that's the only number that x cannot be. For the last 2 minutes, I wanted to show you what this kind of looks like when you're graphing them. So what I'm going to do is I'm going to graph number 7 on Desmos and show you what it looks like. So let me see if I can do this real quick. Let me see if I can share my screen. There we go. Okay, so here I am on Desmos, and I want to graph number 7 real quick. I'm going to let f of x be equal to, okay, what's on top? X plus 1, x plus 1, right? So that's what that looks like. And I'm going to put this in parentheses because I'm going to divide everything by something. Now, what's going to be on the denominator? The 3x squared plus 8x plus 5. There we go. Okay. So now I see what this looks like when I graph it. Now, what you'll notice is our excluded value was what? X equals -5/3. And I'm going to make this a dotted line so it looks better. Okay. So what you'll notice is when I graph a rational function, it kind of looks like two curves. There's a red curve right here, and there's a red curve right here. But it's all the same graph. So what happens when x gets closer and closer to -5/3? What happens? Well, -5/3, that's basically like -1.666 repeating. So if I look at this and I zoom in, as the graph gets closer and closer to this -5/3 value right here, the graph starts to go a little bit crazy. From the right side, what you notice is the graph just shoots straight up. And on the left side, what you'll notice over here is the graph just kind of shoots straight down. So when you get closer and closer to this value, the graph starts taking higher and higher values as you go from the right. And as you come in from the left, the graph gets lower and lower values. So actually, you go up to positive infinity on this side, and on the other side, you go down to negative infinity. So I just thought that was interesting to show you. So what happens when x is -5/3? You're basically dividing by 0 at that point, right? So the graph doesn't really have a value at -5/3. You're not really going to get a value. And that's why you can't really let x be -5/3 and get away with it. You're letting the denominator be 0, basically. Okay?